that the astronauts read out
the gravitational effect of those planets.
Hi, I'm Matt, and this is NASA Now for January 18th, 2012. Before a mission can take flight, it has to go through rigorous testing. This is not only for the safety of the astronauts, but also to ensure the success of the mission. Today, we will be speaking with an expert who is part of a unique team that has been putting a test version of the Orion Multipurpose Crew Vehicle to the test. That's ahead. First, here's what's happening at NASA Now. In October of last year, testing continued at Langley Research Center's Landing and Impact Research Facility, or LANDER facility.
3, 2, 1.
The subject of the test was an 18,000-pound Orion ground test structure to simulate the actual Orion Multipurpose Crew Vehicle. Originally, scientists and developers were looking at land-based landings using airbags. After extensive testing, the direction of the program has been shifted to water-based landings. Testing is a vital part of the research, development, and design process. So how do you test for different kinds of data, and what role does math have in that process? Today, we are joined by Dr. Richard Boitnott, lead test engineer at the Landing and Impact Research Facility located at NASA's Langley Research Center. Hello, Richard. Can you tell us about the current project you're working on?
My current project is on the Orion Multipurpose Crew Vehicle landing test for water impact. We just completed construction of our hydro impact basin. It was filled with approximately 1 million gallons of water. It's 20 foot deep, it's 115 foot long and 90 foot wide, and it allows us, with the use of the gantry, to simulate the velocities that the Orion crew module would have upon splashdown in the ocean.
What conditions are you simulating?
We're actually simulating the velocity under parachutes, and so we're only raising up to about 100 feet, so we're not using the full vertical height of the gantry.
What do you measure in these tests?
Primarily, we are monitoring the deceleration of the capsule as it hits water. The pendulum release takes about 4 seconds, and at 4 seconds we'll cut loose our boilerplate test article from an integration platform, and then the boilerplate test article will fall and develop additional vertical velocity from the free fall, and that takes about 1 second. So we're collecting probably about 12 seconds worth of data, and then we'll collect data upon impact.
Why do you test at an angle using a pendulum?
If you drop the capsule straight into the water, you have more surface area on the heat shield, and that would cause higher G level to the occupants. They have found, and this was also true in Apollo, that if they tilt it maybe at a 28-degree angle, it will penetrate the water and lessen the G load.
We've heard other engineers mention crash pulse. What is this term?
A crash pulse would be the plot of the acceleration versus the time. We have accelerometers at different locations on an aircraft that will measure the acceleration. And then if you plot that versus time, you will obtain a pulse. If it's a very high G pulse for an extremely short period of time, the body may not react to it, and it may not be that destructive to the body. But if it's over a long duration, then we need to know the duration and the G level.
Do you use math in your research?
Yeah, in my job, I use geometry and physics every day. And a lot of the physics I'm using are the high school senior level physics, just to calculate the pendulum swings. And that's important because we have a number of high-speed cameras set up, and these cameras are zoomed in such that if I didn't hit the spot, we wouldn't collect that data.
Why do you do this testing?
The main purpose of our testing is addressed at protecting the crew and occupants of aircraft and spacecraft. Secondarily, we're focused on salvaging the vehicles themselves. But ultimately, they will develop a model and then they will study thousands of landing scenarios. We have 9 tests proposed for the Orion ground test article. But we've used those 9 tests to validate the model that subsequently will be used to study every possible landing scenario.
Designing a spacecraft takes lots of hard work and a ton of testing. See if you're up to the challenge.
Teachers, you and your students will design a rocket structure and put it to the test using Engineering Design Challenge spacecraft structures. You can find it on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to friend us on Facebook and leave a comment about the show. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.